Yes, please feel free to hold the paper.
Sure. Oh,
So,
okay. Oh, that was a great idea. Thank you. Perfect. All
I
right.
can do a little bit more.
We are in business.
So before you do any runs, you have to first set up the method. And so a lot of the operational buttons, if you will, are on this side. So for the method itself, you have to know if you're going to do a wavelength scan, which is scanning the emission wavelengths, exciting at a specific wavelength, or there's other options. So you can click on wavelength scan and see the different times. So you could do a kinetics experiment and measure time, and take time points that it'll automatically set up so you don't have to sit here and click it every so many minutes. And then there's 3D scans. Not sure what photometry is. Potentially, from what it sounds like, it's as if you want to use excitation to create product. And the final one, 3D scan, is if you want to actually scan excitation and emission at the same time and generate a three-dimensional plot, which is, as you change emission, take the excitation, excite, take the emission, excite, take the emission, and generate a 3D plot. Dr. Salzberg used that scan and with Museum of Fine Arts in order to characterize the fibers, the dyes in fibers of silks, some of the Japanese silks. And so we want the wavelength scan, and then you can go over to instrument. And the scan mode we're going to be doing, we're looking at emission for this, not excitation. So you could set it to look at a specific fluorescence emission and scan the excitation spectrum to see what that excitation would look like. But Selena did that for us, and so she knows that the compound absorbs, this complex absorbs at 550 nanometers, and so we can do an emission scan and simply set the excitation wavelength. So we can do emission, we can do, the data mode is fluorescence, and this is also in the procedure that we have on the computer itself. So for the excitation wavelength, we're going to set, it was 500, which was already preset from the last time I ran it. So the excitation wavelength, that's the wavelength. Remember to excite the molecule up into the excited state. We want to make sure we don't look or scan over the excitation wavelength because you could get a lot of scattering and it hurts the detector, which is highly sensitive. So you always want to have your emission start further, lower energy, longer wavelength. So she chose 550. She chose to stop at 700. So the peak is centered probably somewhere around 600. And the scan speed, nanometers per minute, we can make that quite quick. So we could put it at the 30,000, which is the same. 30,000 is what, 30,000 is what Selena said in her thesis. So, so 240 is way too slow. So I'd make that 30,000 to make it the same as what Selena did. Now, excitation slit and emission slit. Now, this has to do with how wide, how much band of emission and excitation. So if we set it at 500 and we set the 5 nanometer excitation slit, that means you're probably going to be going from 497.5 up to 502.5. So it puts it right on either side of that. But 5 is a pretty standard amount. If you go lower than that, you're decreasing the excitation, which also tends to decrease the amount of emission that you observe because this will affect how much light intensity gets into your sample. And you could have entire discussions about signal to noise and things like that with making your slit widths too small or peak broadening by making your excitation too big. But 5 nanometers, both the excitation and emission, is pretty standard. It's sort of like how wide is your eye for letting those in. And the rest of this, I believe, was you can set the replicates to 1 in the beginning right now because we want to make sure that our samples, what I would say is recommend measuring our smallest concentration of ppm aluminum and then measuring our second more concentrated, because you should see an increase. If you don't, then what we'll have to do is do a dilution because what we're getting is quenching. And so we want to test for quenching before we do all of the samples so that you can minimize the excess of work. So I would just set the replicates at 1. And then you can hit OK.
You don't have to look at monitor processing.
Oh, you can look at monitor. I don't think we have to change any of those. Processing will allow you to do smoothing. You can see the Savitsky delay is there, or the mean smoothing as well. We might just try to do it without any type of smoothing at this point, and then go forward. So I don't think we have to do, we could look at report. Yeah, this is for printing, so I think we're okay. It says 550 and then the data end is 600. I guess you can make that 7 because that's the actual range that we're looking. I don't know if this printer works. Most of these are just bookends and paperweights at this point. But let's try hitting OK there. So it's setting up those parameters, and you should double check to see that these are here. And the shutter is closed. So once...
Just one thing.
Yeah, go ahead.
When you made that change, it had stop lit up red. So if you're really quick and it's still stopped, it'll crash the program. So make sure that that stop light is not on.
that's a good point.
Done that.
So I think we're ready to get our samples. The next step is then, I believe if you hit sample, it will pull up a window where it will save the data as best as I remember. This is a little bit different than the program I'm used to. So click sample, yep, and then the sample, you could change the sample name and any comment. This is what I put in for the one test that I did last night and this morning. I also did create a folder for us under My Documents in 341 2016, just to make it easier. So you can change this for whatever. I think 1 ppm was the lowest that we started with outside the blank. So, and then I would just change the comment too.
Yeah.
I think, and the file name possibly, because this is what I found is strange. Even though you change it up there, yeah, it seems as though you had to change it twice.
Okay. Is this the folder? No, it's the first one. Oh, got it. Okay. So
Yep.
Okay.
So it's like 3 places you have to change it. I think you hit OK. And as far as I know, I don't know what the pre-scan function is for.
Pre-scan finds the kind of the optimum point of absorption and emission. Kind of just sets it that way.
Oh, I see. Okay. I've never had that before.
Yeah,
When I use.
I think that's the same thing. Why don't you put the pointer there? Let's see what it says. No, right up to where that is.
Auto pre-scan?
That's the same thing.
I
It
see.
finds the sweet spot.
Got it.
But we know what the sweet spot is.
Yeah, Selena probably did all that pre-work for us because her thesis already gave us these guys here.
Yeah.
Okay.
So we should be able to go just simply to measurement, but we have to put our sample in.
Right.
So we'll bring our samples over. I brought